2.0, where we focus on giving you the opportunity to learn from professionals from various fields to help you explore your passions and interests. Hi, my name is Elaine, and today I will be interviewing Professor Stamps, an associate professor of geophysics in the Virginia Tech Department of Geosciences, specializing in geodesy and its applications to tectonics and hazards. Today, I will ask a series of interesting questions about Professor Stamps' work for her to answer. This video will showcase the highlights of this conversation. If you are interested in listening to this full interview, feel free to tune into our Spotify using the link in the description. Now, without further ado, let's get started. Okay, hi, Dr. Stamps. Thank you so much for coming to this interview. We're really happy and honored that you're here. So to start us off, please introduce yourself, including your area of expertise and a fun fact you would like us to know.
Hi, thanks so much for having me. My name is Sarah Stamps. I am currently an associate professor of geophysics at Virginia Tech in the Department of Geosciences. My specialties are geodesy and tectonophysics. For a fun fact, I've spent more than 2 years on the ground in Eastern and Southern African countries collecting GPS data to quantify how the surface is moving with millimeter precision.
Wow, that sounds really fun and a good experience, like in general. So, you mentioned that you specialize in the field of geodesy. So how did you even get interested in this field? And like, how does it apply to tectonics and hazards in general?
I became interested in geodesy all the way back in high school. I learned about the field of geophysics kind of more broadly at the University of Missouri-Rolla's Jackling Institute, which is a program for high school students interested in science, engineering, technology, and math. The Jackling Institute helped me decide on geophysics in academia as a career. And then when I was searching for universities to attend, I learned about Professor Bob Smalley at the University of Memphis, who uses the Global Positioning System, or GPS, to study plate tectonics. At that time, I really became fascinated with the field of geodesy and started pursuing an undergraduate degree at the University of Memphis and did undergraduate research with Professor Bob Smalley in geodesy.
Yeah, it sounds like Professor Bob Smalley had a really big impact on
He
you.
did, yeah. And we still talk today. He's actually, yeah, a really important person in my life.
Yeah, for sure. So kind of diving more deep into your work, can you explain the significance of GNSS or GPS positioning data and INSAR products in your research about observing how the Earth's surface moves? Like in general, like how does everything work and how do you collect data?
Mhm. So GNSS stands for Global Navigation Satellite Systems. And then GPS is the US GNSS system, the Global Positioning System. So that's a system of satellites that orbit the Earth's surface, several thousands of kilometers away from the surface. And they send down radio signals that are detected with instruments that we can use to monitor how the surface moves within millimeter precision. So we need the global navigation satellite systems and GPS to quantify how the surface moves within a millimeter.
Mhm. So using this positioning data and like numerical modeling, how would you use this to elucidate the physical processes driving Earth's movement? And is mathematics really useful for your field?
Okay. Yeah, so numerical modeling is very much used in understanding the actual motions that we detect with the GPS system or GNSS observations. So numerical modeling is very math and physics based.
Mhm.
A lot of the modeling is continuum mechanics, so using assuming that the Earth behaves with equations that describe fluid behavior. And then to determine surface positioning data and like velocities, yes, there's a lot of math involved.
Mhm. So using this numeric model, how would this connect to hazards or tectonics or helping us predict like earthquakes?
Mhm. So depending on the code that you use, one of the codes I use is called TDEF node. TDEF node allows us to take GNSS or GPS velocities, invert them for large scale tectonic plate motions as well as fault slip. So it helps us to understand how a fault could slip over time. So that's one way that we can take fault slip calculations or estimates and then convert that to calculating predictions for how big an earthquake would be on a particular fault over a particular amount of time.
So would you say that the largest application of your research is for like detecting hazards along fault lines?
I'd say that's one of the applications. Another application is volcanic hazards. And I have a network a GNSS network in Tanzania that monitors an active volcano. There's also a seismic station that is co-located with one of our GNSS stations in Tanzania. And then I have a project in the Chesapeake Bay that I mentioned where we're measuring the vertical land motions, and having better constraints on vertical land motions can then help scientists to better constrain relative sea level rise. And so that's another application, is the hazard associated with sea level changes.
Among your research in all of these locations, can you describe like one moment that was the most interesting or like something that you'll remember for the rest of like your life?
Okay, there was this instance in Tanzania. We were probably on our second or third trip of installing and establishing our GNSS network for monitoring the volcano. And we always do outreach. So we go out to the local communities and communicate the kind of work that we're doing. And there was a moment when my colleague in Tanzania, who he and I did our PhDs together at Purdue, I gave a presentation, my student gave a presentation, and then Saria, my colleague, Dr. Ella Faraha Saria, started answering questions from the local community. And I just remember that moment when I thought it was just amazing that we have a Tanzanian who has gotten his PhD. He's now an expert, and he is the expert answering the questions. It's not some foreign scientist coming in and communicating with the local population. It is a true expert from Tanzania. And I remember that being like an amazing moment, and seeing that happen.
That must have been really special to see. So earlier on in the interview, you mentioned that you operate a real-time network of GNS sensors in Tanzania, and that helps you monitor an active volcano. Could you elaborate on how these sensors exactly work and how the data collected from the sensors contribute to our understanding of hazards and volcanic activity?
Yes. So these GNSS sensors in Tanzania, they collect positioning information every 15 seconds or 30 seconds. And then it collects that information and sends a daily file to the US so that's every day. But there's also the capability that these sensors calculate a position every second, and they send that data every second to the US, or not just to the US, but they send it over the internet. And then that information is parsed and put on an online portal, where if the station goes above or below certain height thresholds, I get an email alert, and then I will go and check if there's some anomalies in the data. And we have a flow chart where a decision flow chart where I alert our Tanzanian scientist, and we have a scientist in South Korea, Dr. King Hyun-ji, at the Korea Institute for Geosciences and Mineral Resources. So there's the South Korean scientist, our Tanzanian scientist, and myself. So the three of us will converge to communicate and determine if there's actual hazard. And then if there is a hazard, then our Tanzanian colleagues will elevate the hazard to decision makers in Tanzania. So that's how that system works at this time. And then we also have a seismometer. So we would check the seismic data as well to see if there were precursory signals for an eruption, a potential eruption.
Okay, so now that we've learned about your research career and got an idea of what your research looks like and the amazing field that you work in, what advice would you give to a student who's really interested in geodesy but doesn't know exactly where to begin?
So a piece of advice I would give to a student is a piece of advice I got myself when I was learning about geodesy and kind of getting involved. And that geodesy, specifically the kind of geodesy I do, which is GNSS or GPS geodesy, requires a lot of patience. So you put out a station, and say a new GNSS or GPS station, and you have to wait at least 2.5 years before you can use the data from that station for your science. So you want to be patient and you want to be able to have, multiple projects going at one time. Work with somebody who has the skills to do this type of research, so you can learn the tricks of the trade. But that would be my biggest piece of advice is patience. And somebody, Dr. Glenn Mattioli, he works with an organization called Earthscope now. He taught me that pretty early on, and that was a really good piece of advice.
Thank you so much for coming to this interview. We learned a lot from today. And I wanted to thank you for taking time out of your day to talk more with us about geodesy. Thank you.
You're welcome. Thank you. Bye.
Thank you, Professor Stantz, and thank you for watching. I hope this interview helps you gain more interest in the fascinating field of geodesy, including its applications and using numerical models to elucidate Earth's surface motions. Please check out our Spotify via the link in the description for the full interview. If you are interested in more content like this, explore all the other videos we have on our channel. We hope to see you in the future videos as we explore other intriguing topics.